All right. Good morning, everybody. Welcome to our IoT Basics session. My name is Mark Williamson. I work as a Salesforce admin and developer.
My name's Larry Allen. I work in actually what's a rather unique group for public sector. I work in a small group that's connected with our CIO's office, and we get a lot of the very interesting strategic and business innovation-oriented projects to work on. So it's a very unique opportunity. York Region is located in Ontario, Canada, just a little bit north of Toronto. Got any more Canadians in the audience here? Yeah. We got a few? Awesome. Great. Welcome. York Region is regional government. We sit a little bit above, or one level above municipal government. There's 9 municipalities within our jurisdiction. We both work in IT, which is 117 people. We service about 5,000 employees, and we have about 1 million residents within our jurisdiction.
So just before we get started, I just want to quickly share what brought us here to Dreamforce to present this year. Larry and I attended Dreamforce last year. It was our first Dreamforce, and we spent a lot of time in the dev zone, and in particular the IoT area, and it really got us excited. All the stuff going on with IoT, into Salesforce with Thunder and all this stuff. I don't know if anybody was here last year. They had a foosball table that was connected. There was a robot that was kind of mirroring a supply chain use case, which was integrated into Service Cloud. It was some really cool stuff. So we got really excited and said, okay, well, how can we bring this back to our organization and leverage IoT? So we went back and kicked off a little proof of concept project that we're going to share with you in a moment. But at the same time, we're very new to Salesforce, being on the platform for probably about 2 years now. And we've consumed a lot. We've been, to people's blogs and to the success community, and we really wanted to give back what we've learned. So we pitched this idea, and now here we are presenting at Dreamforce 2016. One more thing. At the end of our presentation, make sure you stick around to the end. We will be giving away a Raspberry Pi 3 starter kit with all the components that you need to actually build what we've built back in our office. So there will be a question at the end. It's not a skill testing question, but just pay attention to our presentation in the slide deck, and hopefully one of you lucky members gets to take home a kit.
All right, so we're going to talk a little bit, just before we get started on that, most of you have probably seen this before. This is Salesforce's forward-looking statement. It basically says, make any purchase decisions on technologies which are currently available today only. Now, having said that, the only thing we're showing you are technologies that are available today. So when we started talking about what kind of a solution we wanted to demonstrate, initially the concept was around really showing a complete solution to make IoT a little bit more accessible for people that are perhaps a little bit intimidated by it. I know I was a year ago when we started looking at this. And as we went through the process, we found that we actually had a business application for the solution that we built. So I'll give you a little story on what the application is. Over a year ago, our office was operating out of a location where we only had 4 meeting rooms for 120 people, and it was very difficult to get meeting space. We've since moved into a new location. We have over 20 meeting rooms now, which is phenomenal, but we probably won't be able to keep them all. As we do grow, we're going to need space for additional staff, and some of those rooms are probably going to have to be converted. So the problem that we can address here is really to get some metrics around understanding what the right amount of collaboration space is for our business so that we don't end up back in that position of not having enough meeting rooms. So how are we going to do that? Well, we thought if we had metrics around the utilization of the spaces that we do have, and we collect that over time, then we could have some real hard data to inform those decisions in the future when we do have to start reconfiguring our offices. So we do that on the Salesforce platform, obviously, and we're using the Raspberry Pi to do the raw data collection and the data analysis. And we just wanted to point out we are using the Pi to do that analysis. We're not using Thunder. So on the right, you can see the image of the first product that we built. This is using a Raspberry Pi 2 and an infrared sensor, which is underneath the little white dome. And you've probably seen those on all kinds of different pieces of equipment. You have lights that are automatically activated when you go into a room. It's the same technology. We replicated the solution on a Pi 3 when the newer model came out around midsummer. And it is packaged a little bit differently. That's the only difference between the two. But we'll talk a little bit about why the packaging is different when we cover the physical connection of the infrared sensor. So our data flow basically looks like this. We start with the raw data, which is just the hits, the raw data coming in from the infrared sensor. We do our data analysis on that, and we're going to talk about what that algorithm looks like and what it's doing when we go through our live demo. From that, we create our occupancy information, which is basically an occupancy record, which has start and end times. And as we collect that information over time, then we can generate those utilization reports. As an added bonus, we also get real-time availability information for a given space. So our session today is going to start with a live demo. Then we're going to cover all the hardware that's involved in the solution. We'll go over the software, which is basically the OS for the Raspberry Pi, and a couple of libraries that you need. In particular, one called Simple Salesforce, which we use to connect the Raspberry Pi to Salesforce. We'll cover the Python code essentials. Python is the scripting language that we use on the Raspberry Pi, and we're going to cover things like authentication, creating records, and updating records. We'll also talk about the Salesforce Objects. They're very simple for this application, but we will cover those so you know what the targets are for where the data is going. Lastly, we'll show you the utilization report that we built, but the details of that are outside the scope of today's discussion, but there's some great information, great modules on Trailhead if you're looking for some learning opportunities for the reporting. One other housekeeping item, we have a fair number of URLs that we have in the presentation, and I know from my own experience it's great to capture some of those things during the presentations. Because we've got a large number of them, we have a slide at the end of the deck that we'll put up during our question and answer period that summarizes all the URLs. So, okay, get on to the demo.
So live demo. As you know, anything can happen, so here goes nothing.
So what you're looking at on screen, just to give you a brief summary of this, on the right-hand side, you're looking at a remote desktop session that we're running from the MacBook Pro onto the Pi, so you can see the script that we're running. On the right-hand side, you're looking at a live view of Mark's phone, so you'll be able to see what's happening in Salesforce. So we started our script, and what the script basically has to do is understand two things. It's got to be able to identify when a room goes from vacant to occupied and vice versa. So we have a timing loop set up, and you can see one of the first lines up there says first motion detected. So we've captured that timestamp. Now, when the room is vacant, what we're looking for is at the end of this 60-second window, we're going to analyze this data, and we're looking for enough activity to span a minimum of 30 seconds. We don't want to be declaring a room occupied because somebody runs in quickly to pick up a white marker and is out. We want some sustained activity during that time period. So at the end of the 60 seconds, what we'll do is we will update the status of the room to indicate that the room is now occupied, and we'll also see that activity happening on the Lightning component over on the right-hand side. Once that happens, Mark's going to talk a little bit about the Lightning component, and then we'll flip back and we'll look at the reverse situation where we want to declare the room as being vacant. So there you can see we've completed our minute, and we have declared the room as occupied.
So it might look like we're really nervous walking back and forth on the stage. We're actually trying to simulate motion for our sensor here. So as Larry mentioned, it has kind of flagged that our virtual, our room is now occupied. So if I go and refresh my Lightning component, now 2024 Moscone West is now officially occupied. This is a custom Lightning component. We're not really covering how to build Lightning components in this session, but Trailhead has tons of modules and information of how to get started. With this particular component, we've built in the ability to utilize Chatter to let us know when the room becomes available. So if I tap on the room's icon and I say, yes, I want to, this actually gives us some nice real-time feedback of when our meeting room becomes available. And Larry has covered our sensor with a towel to try to simulate our room becoming vacant. And it's now going through its next detection loop to determine the vacancy.
So for our next stage, we want to now be able to identify the room as being vacant. So to do that, what we're doing is again, this 60-second loop keeps running over and over. And we're looking now for, at the end of that loop, we want to see that there's been no activity happening. Now, in practice, 1 minute generally doesn't work that well. Depending on the physical makeup of the room and the size and dimensions and all that, it's perfectly reasonable. We may have people in a room where motion isn't actually detected within that minute. So in practice, what we've done is we're looking for 3 consecutive minutes for no activity in order to change that state. But for our purposes today, for the demo, we didn't want to be standing here for three minutes with looking for ways to fill the time. So we're just looking for 1 minute. So that's now happened. We've changed the vacancy of the room. It's now back to vacant. And the second thing we've done is we've created an occupancy record now. So we've got the timestamp from in the first minute when the room first became occupied. We've got that timestamp, and we've got the end timestamp captured.
And I don't know if you noticed, but just on the top of our Salesforce One app on the phone here, it did mention a Chatter post. And if I refresh the component, live demos always work, right? It should go back to green. Oh, there we go. Okay, so it's now freed up. And in case you missed the Chatter post, the meeting room bot has mentioned that our meeting room is now free. So we can now bring our team in, have a quick brainstorming session or whatever. Also, with all of these in and outs of these meeting rooms, we can produce utilization reports. And we have one such report. Basically, what we're doing with these reports, we're taking an 8-hour chunk and dividing the minutes that the room was occupied by 8 hours, and we're determining our room's utilization. This is, in fact, not production data. It is live, or it is real data. That's my desk at home, back in the office. I've obviously been out for the last couple days. But with this, we can see which rooms are being used more and if we actually really need all 20. So end to end, that's kind of what we've come up with for our instantiation of IoT. Now, how did we do it? Sorry, Larry.
Oh, go ahead.
So starting with probably the most important part is the Raspberry Pi itself. I'm sure some of you are probably familiar with what a Pi is, but just in case you aren't, basically that Raspberry Pi, it's about a credit card-sized computer that is fully capable of running a fully operational operating system. We've chosen to go with Linux. You can run Windows IoT Core, I believe. We've gone with Linux. It's easily powered by a battery source, or you can actually plug it right into the wall. But what makes the Pi really special are the row of pins at the top, the GPIO pins, or the general purpose input-output pins. And those pins give you the ability to connect the Pi to the physical world. So you can put in sensors, like we have our motion sensor. You can put in temperature sensors, humidity, flame or smoke sensors. You can also go the opposite way and actually interact with the physical world as well. You can connect motors and servos. So basically, those pins are what make the Pi really special. So we obviously need the Pi to get our solution to work. To run our OS, we're using a pretty standard micro SD card. 4 gigs is the minimum recommended size, but we recommend actually using probably somewhere around 16 or 32, especially if you plan on doing any kind of multimedia type applications. And so the sensor that we're using is the PIR sensor. Basically, that stands for passive infrared. And what that does is it translates our infrared that we emit from our bodies into motion. And basically, it tells the Pi either a high state or a low state, depending on whether there is motion or there isn't motion. Some simple wiring harnesses to connect up the sensor to the Pi, then I think a power supply, and yeah, so 2 amp minimum is what Raspberry Pi recommends, especially if you're running any kind of USB, maybe a USB Wi-Fi dongle or something like that. It will eat up a little more power. And if you do want to make your project look a little more pretty, you put it into a case, and if you're putting it into the case, it's recommended to use the heat sinks, because there are no fans on the Pi, so we need to dissipate that heat. And as you're getting started with the Pi, you will need to use a USB mouse, keyboard, and monitor connection just to get you off the ground before you need to remote connect into it.
All right, so the process that we're showing here today, we wanted to make sure that we were actually covering all the details that people need to build this thing. So what we did was we wanted to make it foolproof. So to do that, we put together the hardware kit that Mark just described, and we gave that kit to our CIO. And we showed him the presentation, and we said, now go away and build this thing. Now, we didn't have to make any changes to our directions. So if senior management can do this, you guys are going to be fine.
So, he is in the audience today.
Yeah, we can say that because John's here. Raspbian is the name of the OS that we're using on the Pi. It is the recommended OS by Raspberry Pi. You can get a simple installer. You just download the installer. You extract the files from that package onto your SD card, formatted for FAT32. And that's pretty much all there is to it. You take that card, you put it into the SD slot on the underside of the Pi, boot the thing up with your mouse, keyboard, and monitor connected. You won't need those to remain connected once you're using the product, but for your initial setup, you'll need them. You're also going to need internet access for the next few steps in order to refresh some libraries and get some additional libraries put onto the Pi to make it fully functional for the solution. So you boot up your Pi, complete any of the initial setup directions. One thing we should mention, if you do buy a kit, or for the winner of today's kit, often those SD cards will come already loaded with the OS. So you don't have to download anything. All you have to do is boot it up. It will often give you a choice of a number of different operating systems that you can install. So it gives you some additional options to move forward with.
Okay, so as Larry explained earlier, we did use Python to actually do all of the detection of motion, whether our room is occupied or not. But before we get into Python, there are a few steps that we have to do on our Pi to get set up. The first of which is apt-get. We have to update apt-get index. Now, what is apt? Apt is, well, apt stands for Advanced Packaging Tool. If you're working in a Linux environment, apt is your best friend. Basically what it does is it simplifies the software management process. It handles the retrieval, the installation, configuration, and removal of software packages and libraries. So think of it maybe a little bit compared to like a Windows installer or something like that. Only apt goes one step further, and it'll also handle dependencies for you as well. So it's definitely your best friend when working in a Linux environment. So the first line that we're going to do is we're going to update the indexes for apt so that it points to all the latest and greatest libraries and software packages. So once it's updated, we do need to install one package that will allow us to remotely connect into the Pi. You can remotely connect via SSH, so a terminal level. But for this, we did it just with a regular remote desktop connection. So that's where XRDP comes into play. That'll allow us to remotely connect. Next, we're going to install a utility that runs on top of Python. We're not actually installing Python here because most distributions now that are built for the Raspberry Pi already come with Python preloaded. But we do need to install Python pip. Now, pip is basically like an apt for Python. So the next line, we're going to actually use this pip utility to install a library called Simple Salesforce. Basically, what Simple Salesforce is, it is a RESTful wrapper for Python to integrate into Salesforce. So it basically allows us to really simplify our code from 20, 30 lines down to maybe 1 or 2 lines. Simple Salesforce was originally written by a gentleman by the name of Nick Catalano, but is now kind of supported and maintained by the greater community.
So next thing you're going to need to do is connect up your infrared sensor. We've got the wiring diagram here on the left, and on the right, that's a photograph of our original build with the Pi 2. One thing we should mention, when you are connecting and disconnecting any kind of sensors or making changes to the Pi, you probably should power it down, just to be on the safe side. When we built our Pi 3, we've got an image of it here, and if you watch closely, you'll see that the connections have not changed. We did change the packaging, because what happened when we built our Pi 3, we were getting false positives from the sensor. We did a little bit of research on it, and we found out that there is an interaction happening between the circuit boards when they were in close proximity. So the only change we did have to make was to get some distance between them. So we put a 1-meter cable on the infrared sensor. It fixed the problem. Everything else is identical. Libraries, script code, everything else is the same. Something else we should mention, the numbering scheme for that GPIO port, there's several of them. Depending on which language you're using, and we're using Python, you may have an option of using one or the other of these numbering schemes. And in your code, you're going to have to identify which pins you're connecting your devices to. So it's important that you know which scheme you're using and that you identify that properly. There are certain languages, if you're not using Python, there are other languages that don't give you an option, so you have to know which one your language is supporting. Something else we should mention is you'll see the voltages on the pins. It doesn't sound like a very big difference between 5 volts and 3.3, but it is significant. Make sure that your sensors, the specs on them, or your devices match the voltages on these pins, because if you put 5 volts onto a 3.3 volt pin, you're probably going to damage the Pi. And all of the yellow pins for data in and out, those are also 3.3 volts. And by the way, the pinouts and the numbering schemes, everything is identical between the Pi 2 and the Pi 3. So getting right into the code, there's a few libraries that we're going to need. This first one is so you can actually interact with the GPIO port. You're also going to need a time library, because in our case, we're creating records on Salesforce that have timestamps. So we need those APIs in order to get the information that we need. And last but not least, of course, we're going to need the simple Salesforce API. We need to do a little bit of setup on the GPIO port. So this first line, this is where we're actually specifying the numbering scheme that we're going to be using. We are using pin number 7, as we had indicated on the previous slide. And the last line is specifically saying we're looking for input on that pin from the PIR sensor. So once we connect, in order to connect to Salesforce, we need to do our authentication. Most of this is going to look pretty straightforward. You've got a password, a user ID. The security token you may not be familiar with if you haven't used an API before. So when you're working with the APIs, there's a security token that you also need to provide. Now, Mark's going to talk a little bit about how you can get this thing. It's not something you can look up, but you can generate a new one, and that's unique to your Salesforce user ID. You also need to indicate if you are working on a sandbox, you need to specify that so the authentication will work correctly. So we're going to update one of our records. So this is our simple room object where we're storing the state of the room. Our line of code there has a interesting character string at the beginning of it, if you're not familiar with those things. That is the actual room, the unique room ID identifier, and we'll show where you can find these for any type of Salesforce record. The other thing we need to do in our solution is we need to create that occupancy record. And here you can see we are using the same room identification code, and that's obviously because we want to associate those records with the same room.
Right, so Larry mentioned we need a security token in order to authenticate via the API. That is true, that we do need this security token. We've chosen to use this method of authentication for our proof of concept. But I just want to make a note that if this were in a live production environment, it would probably be more preferable to use a connected app and then use a proper full OAuth flow. We're not going to get too deep into that in this session, but there's plenty of documentation in the developer guide for that online. But if you just want to get something quick and dirty off the ground, proof of concept wise, we need a token. In the classic setup, basically you go find your name, go down to your settings, reset your token, and it will send you a new token in the email, or in an email form rather. In Lightning, it's very similar Lightning experience. You're going to go find your avatar, navigate through the menu, My Personal Information, and reset the token. One more thing to note that if you do change your password for your user in Salesforce that you're using for this integration, the token will also need to be reset again. ID, this is probably not new to most of you in the room, but just in case, to get your record ID in Salesforce, it's basically as simple as navigating through the browser user interface and looking up in the URL for that ID. This screenshot is specifically for a classic UI. Lightning, it's slightly different, but the ID is always up in the URL.
One other thing we wanted to mention, if any of you have ever worked with two different systems trying to pass date-time information between them, you probably found that they all have their own unique way of storing that information. So Salesforce uses coordinated universal time, and you pass that information in simply as a string. So for example, this is the start time of our session today in Greenwich Mean Time, and it needs to be formatted to look like this. So it's pretty straightforward. So we've got the date, we've got the time code in 24-hour format, and Z or Z or Zulu, if you're more familiar with aviation terminology, or military time, that's the format you need. Now there's a number of different ways to do this in Python script. This is the method we used, but as long as you get your string into that format, anything will work just fine for you. And in our case, we're using this where we're creating that occupancy record, so our start time and end time are both formatted this way.
So that takes us pretty much to the end of the code portion of our proof of concept here. So all of this code, the Python, is available. We've created a repo on GitHub, and we'll have these URLs, I think, at the end as well to get there. So we have the Python script. There's also like a little usage kind of README file, as well as a PDF of actual steps to reproduce this project in your own org.
Right. And in the source code that we've provided on GitHub, we've actually set up a lot of the parameters as constants at the beginning. So you just have to provide your room ID, your password, username, token, all that, just at the top of the code, and everything else should run for you just fine.
So that being the code portion, the actual declarative programming part of this is very simple. We've used two custom objects in Salesforce. One, a master object called a room. Basically, it holds a name, a description, and whether the room is currently occupied or not as a checkbox. The detail to the room object is the occupancy object, which stores records about actual, durations of the occupancy in our rooms. Very simple master detail relationship with a start and end time and one formula field to make reporting just a little bit easier on our utilization report. I should note that the master and detail relationship is okay in this instance, but if you're doing a true IoT solution with many detail records, like thousands upon thousands, maybe tens of thousands, well, you might want to use Thunder, but if you don't have licensing for Thunder and you want to try it in regular Salesforce, it's recommended to use a lookup relationship instead of the master detail. So that kind of brings us through our whole, of how we built our IoT sample, but where can we go from here? I mentioned with the GPIO pins on the Pi, the sky's the limit of what you can connect to and from this device. We can do things like I mentioned, temperature sensors, for example. So say you have a server closet or something like that in your building, or a data center, and you want to start monitoring the temperature and humidity in there. We can do that with the Pi. You can talk into Salesforce and maybe create a case if the room gets too hot, right? And that sends out to your property services people, and they come over and figure out what's going on. That's just one example. There's so much stuff you can do. Basically, your imagination is the only limit here. The Pi is also capable to take in a video camera, and there is some open source software out there that can actually analyze moving objects in video. So you can track traffic on a road or cars in a parking lot, for example. But basically, yeah, your imagination is the limit with what you can do with this fairly cheap little computer.
So we're going to get to our Q&A, but we've got a Pi that we're going to give away first. So our question is, we had a small graphic on one of our slides of an animal. Did anybody notice what that was?
Yep.
Awesome. You've got a Pi.
Good job.
Do you want to run it down?
Yeah, all right.
So as I said, we've got a summary of all the links that we had up, plus there's a few additional ones here. If you're not from Canada or the US and you're looking for these components, probably look locally. You'll save a fair bit on shipping, and it's always good to buy local. So we'll open up the floor if anybody's got any questions you'd like to ask.
Yep.
Yes. Right here.
Run the mic around.
So it's a little hard to see with the lights.
Oh, sorry. Okay.
Sorry. Is this on? With the PIR sensor, I've noticed that you have to be pretty close to it. How do you solve for that in a larger conference room? And do you just use one?
It depends on the size of the room. The sensors that we're using actually have a pretty good range of about 15 to 20 feet. We were just, being a little bit more animated here to make sure we were getting exactly the data that we wanted.
You can definitely use more than one, though.
Yeah.
And I would recommend that for larger rooms.
For larger rooms?
Kind of putting them in each corner. You would have to probably alter the algorithm that determines whether the room is occupied, but...
Yeah, but you could do it still with one Pi, just multiple sensors on the one device.
So I have a question. What if there is no Wi-Fi where you're locating any type of sensor? Is there some sort of 4G model that you can put on the Raspberry? That's my first question. And also, what if you want to track GPS location? Is there a model that reads the GPS signaling, or you may need to get that from the internet connection rather from Wi-Fi or the 4G network?
So your first question was around if there's a lack of Wi-Fi?
Yeah, in a farm or something where there's no internet.
I mean, there are other wireless protocols and frequencies that you can use. There's a lot of stuff going on around like a 433 megahertz little wireless module that you could use. I don't know if I'd recommend it, because then you'd have to build the same receiver somewhere else to actually take that data. So really, to get this off the ground, Wi-Fi is probably going to be the easiest way. Your second question about GPS, I believe they do have GPS modules as well that can run off of the GPIO pins of the Raspberry Pi. So that's pretty accessible as one of the sensors. Yeah.
Thank you.
No problem.
Hey, when you guys were first deciding what stack to use, you went with Linux and doing development in Python. Did you guys compare and contrast other solutions for your tech stack that you were going to put on the Pi? Or did you just go with what you know?
We just went with this. Like I said, we were brand new to this, so when we were doing research, these were the examples we were finding, and it just worked so well, we just stuck with it.
All right.
It's basically what we were comfortable with, but you're definitely not limited to this tech stack in any way, even on the Pi. It's whatever you're comfortable with, basically.
Thanks.
Yeah, no problem.
Sure.
All right.
Anyone else? All right.
Any other?
Thank you very
one
much.
More.
Oh, we do have one more.
Give it up to this guy.
I was just wondering if you'd tried to integrate a sort of booking system as well for the meeting rooms too, and sort of occupancy and what's coming up, like display for the meeting rooms.
We certainly could. we do our meeting room bookings in Exchange, and certainly with Salesforce, we could extract that information from Exchange and do some comparisons. It's actually interesting you bring that up because we often do have cases where a meeting room is booked, but nobody shows up. So it could help identify those cases as well.
Yeah, and quite often, like, bookings, don't get put down and stuff like that, and then they actually get used as well. So, interesting.
That'll be our next year's presentation when our CIO sends us back. So be sure to come
Sweet,
back.
I'll see you then.
Yeah. Thanks.
Cheers. Thanks.
One more question.
Sure.
Yes.
So, did you experience disconnecting from Salesforce and you have to reconnect from time to time, or
Sorry?
Sorry?
did you experience disconnecting from Salesforce while you're running your program and having to reconnect from time to time?
Not yet, like disconnecting, so losing like internet connectivity?
Not internet, but connection to the Salesforce org.
Not as of yet. We still haven't really implemented this in a full production environment. We're still kind of playing with it as a proof of concept. But I leave one running at my desk at work, and it's been, I guess, probably a couple months now, and
Okay,
so far
it's
so good.
continually connected to the Salesforce.
Like the Python script should kind of handle those kind of exceptions. If you lose connectivity, it should be programmed in to try again.
Okay, so you have like a retry loop.
Yeah, and that has to be kind of manually put in, but it's fairly easy to do in Python.
Thanks.
Right.
That was awesome. Will you guys post the slides somewhere?
Um,
Are you gonna post it
I
on-
believe Salesforce will be
Salesforce
posting
posted slides?
slides.
Great. And next question was about the lookup versus the master detail. Why is that at such a large scale you need to look up records?
Yeah, I've just read Salesforce documentation and kind of guidelines that they don't recommend using a master detail relationship if you intend to exceed 10,000 detail records. I guess it's just too taxing on the system.
Right.
But in this case, we're not producing quite that many. But yeah,
Thank you.
no problem. Okay, thanks for coming.